My name is Nguyen. I'm the business manager for RIEGL, division manager for RIEGL USA here in our headquarters. Just opened when we moved in at the beginning of December this year, and it's been amazing. We got a brand new facility, and we're expanding here in North America. Sales, service, training, support, all that's done out of here in North America. So for our North American customers, it's a good benefit for them, for us to be local here in the United States. And we try to keep a lot of the work here too as well. Anyway, so if you have been paying attention to our recent releases and stuff, we have some new tools in RiSCAN Pro, some new terrestrial product for new applications for terrestrial scanning. So yeah, just hang with me and pull back a chair and yeah, we'll get started. I'm not going to keep the video on the entire time, but I figure I'll let the audience see who I am if you haven't met me before. I've been with the company for 13 years, since 2008, and it's been great. So let's go. All right. We'll start out with the agenda. Robotic integration with the VZ I-Series instrument. So we have really been testing a lot of robotic platforms to really increase productivity, increase safety, make data acquisition much more efficient to carry out larger projects. You know, because at the end of the day, carrying this tripod scanner around could take a toll on people. So by integrating these scanners, terrestrial scanners, onto a robotic platform, it really is something game changing for terrestrial laser scanning, especially on the new RIEGL static rail system too as well. So that's something that neat that I'd like to share with you guys in a little bit. Some new updates in RiSCAN Pro. So we have two specific names for it, which I'll show you later throughout the presentation. But for now, we'll just call it the new point isolation tool, right? Because that's what it does. It moves points. It isolates points that has been only been captured by one scan position, right? But tools allows us to expand on how aggressive you want to be with your filtering. But yeah, ultimately this removes noise, or sorry, not noise, but points that pedestrians, people walking by, cars that are driving by, that really gives you a good clean data set for modeling presentations, and also reduces the amount of points, unwanted points in the project. And then the anchor point, right? So this is part of the registration and a part of the workflow we have for static scanning. So particularly for indoor scanning. So, and when we first started this automatic registration, we really rely on the aspect of moving consecutively from one scan position to another, and more like a snake pattern, right? So you don't want to jump, let's say you're scanning a building, you don't want to jump to the north side all the way down to the south side, right? You want to continue the path and continue the same path. But with the anchor point, now it allows you to stop scanning for the day and then come back at a different scan position, so that the automatic registration will know where was that point at, we call it the anchor point, to begin the new registration from. So this is good for indoor large project, right? And we have some examples to show you what I mean about that a little bit later. And further research and development. So of course, we're always expanding our applications, hardware, software, and also now this new type of export is FIC, which is an exchangeable data format, and directly into BIM for comparison to as-built, design-built, and construction and project management related. Project map update. So we also have a new update on our project map. So those of you who have not been utilizing the project map, of course, the automatic onboard registration has to be enabled, and it has to be done in order to make use of the project map. Well, we've updated that so that now when we're viewing the project map on an indoor, large-scale, multi-building, multi-story project, it displays only just the top view, so that you don't have a bunch of positions in the view, so that you can easily identify the area of coverage and then where have you scanned throughout the project. And then last but not least, mining division news and updates. So we have 3 new mining apps that we have tested extensively, real-world tests, real-world applications, so that I want to share with you a little bit later throughout the presentation. So yeah, let's continue. So before I move along, I want to introduce you to 2 special colleagues of mine that's really behind the scene and have been in charge of our terrestrial laser scanning division and segment. Mr. Macaulay Nicolaus Studica, sorry. He is the manager for TLS Business Division. He oversees and really puts the scanner to the test. He's done a great job at making a believer of our system, right? So, you know, our systems is fast, it's automatic registration, it does all this neat functionalities and cool features. He's the one that really puts it to the test. You know, he uses all the attributes of the scanner, you know, put the scanner through extensive testing, scanning for hours, doing hours, and collecting thousands of scan positions, just to make sure that what we release, what we have on paper, it all works and is all true, right? So he's played a big part on our terrestrial laser scanning developments and future developments. And then, of course, Mr. Thomas Gasker is solely in charge of the mining division. So these scanners has played a big part in the survey, mapping, engineering, but of course, mining is also a big segment for us too as well. We have mining applications and mining companies all over the world, and we're everywhere in the mining industry. And Thomas has done a great job at not only developing and applying the scanner to the mining industry, but also testing out all the apps and listening to our customers and making sure that all the applications in the mining can be carried out through the scanner, if not integrated with third-party partners, integrated with software to develop a system so that the mining can be, you know, utilized with terrestrial laser scanning division. Right. So if you haven't met these 2 gentlemen before, hopefully you guys will get to one day. And yep, they are solely behind our terrestrial laser scanning segment division and future development. Okay, so let's just get started to our first unmanned vehicle. So the whole idea of mounting this thing on top of a vehicle is no longer an idea, right? It's true. It's happening, right? So even here in the United States, we see a lot of customers now are just mounting this thing on cars, on ATVs, pretty much, you know, anything that can move and stable, we can put it on. Here you see a fine example of a company called Material, which is a European company that makes these manned vehicle. And this vehicle is unique. It's 100% electric. It's approved to be on the road. And this application that you see here is collecting tree in urban and city environment, right? So it's not intrusive. It's not. It doesn't take up a lot of space. It doesn't take up a lot of room. It's a one-man operation, and the whole thing is completely automated, right? Besides the driver has to drive there, and then he controls the scanner directly from his phone, or using our apps, he can also scan automatically, which makes more sense a little bit more when we get into the fully autonomous vehicles. Yeah, you can see here he just drives and we just call it stop and go. I mean, it's nothing new. You know, we've done a lot of testing with it, but now it's no longer an idea. It's here, and people are making use of it. And of course, this is not mobile scanning. This is still static scanning. and the information and the detailed information you get from static scanning, we've all seen and known is well beyond more detail than kinematic scanning. So besides that city tree modeling, here we have a venue digital twin application, right? So this is an older venue, opera house, and this setup is quite unique, and the data I'm going to show you next is going to be incredible, right? So yeah, we work with 3D laser scanning, but on this particular setup, we have included several Sony Alpha digital cameras for photorealistic animation, right? So photorealistic modeling, and the sample I'll show you here in a minute is going to be absolutely incredible. Again, these are carried out through my colleagues and done extensive testing over the years, and we really came up with a good solution for modeling in such dynamic conditions as you see here. And then from there, we can take the data, not just the LiDAR data we can process in RiSCAN Pro, but we bring it in the imagery into reality capture, and then using an Unreal Engine platform, we can then make a really nice model from the images too as well. So yeah, the camera itself is on top of the scanner, but the vehicle is also outfitted with 3 additional Sony Alpha cameras for photogrammetry, for photorealistic modeling. Now, here's a great example of what the Unreal Engine was able to put together. And you can see here, this is at one point, this was a Curie, but now it's transformed into an opera house. You can see is the incredible rendering job and photorealistic model that Unreal Engine is displaying here. Okay. All right, moving on to the next platform. So this platform, my colleague has been testing. It was one of the first platforms that I really saw that was robotic and fully autonomous. And what really made it fully autonomous, when I say fully autonomous, once you set it up, you don't touch it at all, right? And not even in the scanning part. So the robot is programmable and the scanner is programmable, and then really all through an app that the scanners have capability of Python scripting. You can really customize the scanner to however you want. So here with the combination of a fully autonomous vehicle, robot, matched and integrated with a fully automatic 3D laser scanner, you really get a product that you can then now open up different applications for, so such as here cave scanning, mine. I can see an application for sending this thing into a hazardous area where you don't, it's not safe for people to go into. So they send this robot in, and they can capture the data, completely automatic, and then come back out and give the results, right? And beyond that, we can also connect to and upload the data to different networks too as well. So yeah, you can see here back in 2020, this was a team that brought this robot into a cave and did some scanning with it. And then on the right-hand side, you can see it's an underground mine. So yeah, the application just starts to open up. All right, and our last but not least, robotic system is a brand new product, which was recently released a couple weeks ago at Energio. So if you saw our Energio announcement, you already saw this platform. This platform is quite unique. It's a rail system, obviously, and it's also completely fully. It's a robotic rail system. Sorry, and this rail system, it's very versatile, right? So you can expand the width of the wheel to accommodate different rail size. You can elevate the scanner to different height. So if you're doing tunnel scanning or outdoor rails, indoor or underground rail, you can really fix the scanner to tailor such conditions. But yeah, everything is powered on its own. If you look at the specs here, it weighs about 50 kilograms, so it's a two-man, it's a two-man operation. And when I say operation, I mean like putting it on the track and getting off the track, right? But once it's operated, you really just need to monitor it, right? So it's completely self-autonomous. Lithium batteries, so the housing, the base of the base down here where it says VMR, that base has a computer, has batteries to power the rail, so it can move from one position to another, and it also can power the scanner too as well. But I can see it putting other instruments on there, such as IR camera or hyperspectral camera, or different type of instruments to do rail inspections on. So this is just a platform that moves the scanner from one position to another. So I can see it being integrated with different platforms. So yeah, if you have ideas, if you're interested, let me know. And we certainly would love to work on new projects and new go rabbit hole with you if I certainly will. Yeah, it's got a long endurance hour of up to 8 hours of working. So this is only preliminary testing. I do believe it is available, and if you're interested, let me know, and I will give you delivery time and all that. I have all the information and cost too as well. Yeah, of course, not only that's fully autonomous, it also has an emergency stop. It can go every 30 feet, or you can make it shorter if you want. The adjustable arm height can go, elevate up and down to accommodate the height of the system. And then, of course, the adjustable track gauge too as well. So yeah, these are just the specs. And the data sheet for this is also online too. So you visit our website, RIEGL.com. You'll be able to find this product. All right. So now let's move on to the test that we did with this. So here is a track, outdoor track that we put the system on. So the system itself is easily transportable and adjustable, automatic registration in parallel with automatic data acquisition. So using the app, you can program the scanner to acquire data completely on its own. So at the end of the day, the person that is operating the system is literally just watching it. Yeah, we're not really doing anything to it. And on this project, here are some attributes of the project. So at the first scan position, it was approximately 11 o'clock. And then just under 2 hours later, we were able to cover 1,800 feet of track, right? Feet of track, 1,827 feet of track. And that's at the 79th scan position. You can see here is just under 2 hours. And then another 2 hours, you can see now we're at 3,556 feet, right? So within 4 hours, we can cover easily a 3/4 of a mile with the track, and completely autonomous. And the detail information you get, and I have data from this too as well. So if you want to take a closer look at the type of detail you can get from a terrestrial track system, rail track system versus a mobile rail track system, and both system has its own application and its own place in the rail industry, right? So yeah, of course, we're not here to set up the system to do tens of hundreds of thousands of miles or kilometers of track, but I can see this thing being very easy for railroad inspections or off lines, right? So if you have a company that has its own track line off of the main track, you can use this thing for quick inspections, right? So you don't need to schedule a vehicle to be on the track. You can put this thing on a track at, when there's another train coming within a time period. Two people can put it back on the track, get it off the track quickly. So you don't have to shut down tracks and you don't have to shut down rails to really use the system, right? You use it accordingly and plan it accordingly. I think there's a place for this track system for sure. And the detail you get from it, I don't know if you've seen terrestrial tracks data versus mobile track data. It's night and day. So yeah, if you want to take a closer look, let me know. And if you're interested, we'll do a webinar and I'll show you what the data looks like for sure. But so in about just under 4 hours, we're able to cover 3,556 feet of track. And of course, the system is so user-friendly and so user-defined, is that if you have the track system and it needed to be down to server control, it can automatically detect targets too as well. So like this 400 merged with this track system is like the future of static rail scanning, I think. But so it's quite unique on the flexibility and the user defined capability that you have with this type of setup from the RIEGL VMR and the VZ400 or 2000i. Yeah, the distance between each track is each camp position is about 30 feet. Of course, I think you can get higher, and I'm willing to bet that we can make extension poles to even get higher than what it's at standard right now. So I don't doubt that this thing can go much higher too as well. And then the higher you go, of course, the further you can move apart, right? But then it's up to you about the details you get from the different camp positions. And then our scan pattern, that's our go-to scan pattern. It's Panorama 40. So it's an angular resolution at 0.04 degrees. That's approximately 7 centimeter at 100 meter point spacing. So that's considered a high, medium to high resolution point spacing. All right, so here's a quick video of this test. So we know the static scan time. We know the speed of the rail. The speed of the VMR. We know how, where, when it will stop. So you can really quantify the time it would take to do X amount of track. So by knowing these attributes, you can really schedule these scans and for maintenance purposes on a routine basis, right? So, and then without, like I said earlier, the advantage of this is that it's a quick operation for deploying it and then also taking it off the track, so that you don't really need to schedule any downtime for these tracks and to stop any trains from coming through and coming onto these tracks. A lot of the tracks are used for procurement, delivery. So we try to prevent any stoppage from that. But that's a great video of that. So software. I think this is a new tool that a lot of us has been waiting for, including myself, of course. It's the new point filter tool. So this will isolate and it will index the points into a different folder, so it doesn't delete it, right? So it just kind of like, I don't know, I guess you can call it classification. It just classifies these single points that's been hit by a scan only one time. I'll show you some example here in a minute. But you can find it in the new one-touch processing wizard, right? So task number 8 and task number 7. And from there, you can see next to it, there are different settings that you can implement, right? So for example, search radius, tolerance, and stuff like that. To make it more aggressive or less aggressive. But the cool thing is that it works so well. Like I was blown away when I initially saw it, how well it worked, and it just really cleans up the data extremely well. I have some fine examples to show you here in a little bit. And the whole point is to delete moving objects, right? And it's been a long time going. And what's unique about this is that I've seen this tool before. I've seen it before with our competitors, but you have to take multiple scans from one scan position to detect moving objects. We don't have to do that. We only scan it one time, but when we don't hit it from a second position, we consider that a moving object. So if a car drives by, most likely you're not going to hit it from the second scan position. It makes perfect sense, and it's brilliant, and it was so, I don't know, it was brilliant. But here's some fine examples. So here's a bridge that was surveyed, scanned. yeah, by many scan positions. I think about 4 hours and 200 scan position. Of course, the product data is not there, but yeah. So from there, you can just run that wizard. And of course, all the people, all the cars, all the jobs are gone. The cars that are there were stationary, and it was working on the bridge. So of course, that's going to stay. Yeah. So that's before, and that's after, right? Here's an example of a courtyard in the city. These things are always a mess to scan because there's people everywhere. So there's the before, and then colorize after final product. Yeah, brilliant. Okay, so moving on. So another new function that has been implemented and improved for both the RIE project app and also the RiSCAN Pro. Now it's possible to go back to an already registered scan position in the field at any time. So what this means is that, for example, if you're scanning an indoor interior space where you have closets, mechanical room, engine rooms, etc., offices, you can't really loop and keep going, right? You're gonna have to eventually go back out and go down a different hallway or a different path. Well, the anchor point position allows you to do that now, and it allows you to continue the registration from where the anchor point is. Yeah, that doesn't make sense. This next image should. So what that means is that from 1 to 10, now you can go back to 1, go back out of that room and start in a new room, but the positions registration doesn't begin at 10, and now begins at 1 through 11, 12, 13, 14, 15, 16, 17, and so on. You can have as many anchor points as you want, as long as you tell it as an anchor point during the data acquisition. So on the scanner itself, you'll see anchor's position, and then you just say, yep, this is the anchor position. That's where you're going to pick up tomorrow. So this is great for indoor project where you know you're going to be scanning multiple days. But hey, if you're fast, you can maybe do it on one day. But yeah, this is great for, like I said, indoor project that you know you're going to be spending a lot of time on. And to get the registration perfectly, this new anchor position really helps out with the registration. And that's really what it all is. It just helps out with the registration. So it doesn't always begin in a chronological order from 1 through etc. or X. It can then begin at anywhere you want that you set as an anchor point. But you always have to start from an anchor point. Yeah. So your next position should always be where the anchor point is. So yeah, this is great for indoor scanning and whatnot. And here's some more examples of that being used in this particular project. This is a old furniture store that my colleagues scanned, and with multiple levels. Yeah. And the new updated RIE project map. So you can see here from the top view, you can see how there's a scan position underneath each other. But with the new project map, you can update it. I think it's at no cost. It only shows just the layers that you want to see, right? So instead of seeing all 6-story, when you look at the project map, it only shows just the top layer. So you only see just the position that's on that floor. So yeah, so that's a new improvement to the project map app. And again, if you don't use this, I use it all the time now. It's great for demonstration, and it's great to use when you're doing a project on a large scale, multi-story, indoor, outdoor, because it really gives you a good, a good confidence on what you have scanned and where you have been, right? So for example, if you're doing an indoor project and all of a sudden you see an empty space or like an elevator shaft or a closet or a mechanical room that you forgot, yeah, if there's no circle or blue dot in there, it's probably because you haven't been in there yet. So it gives you a good understanding where you need to go. So, and of course, this only works if the automatic registration works. Otherwise, this app will not work. Here's an example I want to show to lead into my next slide. So this is an X-ray view, very detailed. I think a 5mm Optree filter. You can see this is the same building, by the way, and this is some of the duct vents that was in there. So some new development that we recently that we are going through now is how to export an IFC data set to go into a BIM, right? So we're getting a lot involved with BIM. BIM's popular, and an IFC data set is an exchange format that doesn't distort the original information, right? So it's pretty much just like a PDF, a PDF that you can export out or and then bring it into a BIM platform to compare as-built and 2D drawings to, and we want to do that all within RiSCAN Pro. So I think that's pretty neat for our BIM users, for BIM applications and of course BIM users. So yeah, it's going to be a great way for us to keep everything within the software RiSCAN Pro, so that we can bring in a 2D and compare it directly to the IFC file. And the IFC, it's not really a format, right? So it's kind of more like a schemer. So, but then you cannot edit an IFC file. You have to make other edits in the data and then re-export an IFC file or the changes. And plus, you shouldn't be able to change an IFC file anyways, or data set or file, whatever, anyways. But yeah, so we're working on that, and that's some of the new developments and research that we are currently doing right now. So yeah, so stay tuned for that. Okay, so let's move on to our last, I only have 30 minutes here. I think I'm maybe running over. So let's move on to our last, but not least, our mining division. And these are some of the contents I'm gonna be talking about. So mining has, like I said, it's a big industry for us, and we have a huge customer base worldwide, just not United States, all over the world, Australia, Africa, you know, Europe, Canada, all over the world, here in the United States too as well. So we've developed some new monitoring apps, design apps, and slope angle apps, right? And these apps are just not developed. It's been tested. We've tested them. My colleague Thomas Geisler, he's the I showed you earlier. He is when I introduced you to him earlier, he's the head of our mining division. He's done a great job at connecting and really testing these and making these use and perfecting these apps so that it could really apply to the real world of mining. And then also he recently teamed up with Rotec, Hortz, and Superior to build a berm monitoring system. I have an awesome video to show you on my last slide. Yeah, but let's go ahead and look at some of these apps, right? So the first one is the monitoring app. So this app, it's a very good way to stationary permanently mount a system somewhere, so that you can continue to scan an area and monitor the changes within that area. So if you're looking for if you're at a hazardous location, you can set it up and teaming up with different software like BMT, which is a visualization platform, online data view platform. You can really see the results in near real time and activate alarms and see all the changes of the slope or danger of landslides and such within the mining environment. You can see here on the left-hand side, it's a scheduler, and then you can reference it and compare it to whatever time you want it. Like again, the scanner is completely programmable, that you can scan it whenever you want, on any day, on any given time. And also the scanner orientation adjustment. This is something that we really haven't talked about yet. This is very, very important, right? So, and any kind of platform that you mount your system in a mining environment, it's gonna move. I don't care if you drill 5 feet, 10 feet concrete pillar into the ground, it's gonna move. And what this scanner orientation adjustment does is that it allows you to correct the roll pitch yaw value if it senses any kind of movement from the original scan, right? So it's brilliant, right? So therefore you don't get any false information and false detection. Yeah. So without that, you know, because the scanner is going to move, like I said earlier. And then on the right hand side, you can see, oops, sorry. And then on the right hand side, you can see there are thresholds that we can set so that when it reaches that certain threshold, we can raise an alarm or stop mining in that area because of danger. So Yeah, and this is an online web-based view, right? All the data is set up to a network, whether it's through a cloud or an internal NAS drive. The data is completely online within that network, a secure network, so that it goes into this web-based data view, so that we can then monitor it in such condition. All right. And the next app is our design compare app. So this is unique because we can then upload a model to compare the area that we're excavating from, right? So whether it's overfill or undercut, we can see here to the right hand side it shows an area overfilled and an area undercut. So as the as the excavator is moving dirt around, they can know when to either stop or or continue or and such. So we compare this directly to a model. And the last one is the slope stability angle app. So here again, it just easily is detecting the angle from vertical. So if we set a threshold of whatever angle we need that slope to be, we can then scan it, compare it, and then the app will automatically tell us based on a color scheme where the threshold would be to either exceed the maximum slope angle. All right, and then moving on. So this is a BIM monitoring system by Rotec, Hortz, and Superion. They have put the system together for safety, right? So in the mining industry, safety, I think it's top priority, and they will, spend countless hours of research to really implement any kind of safety system. And I think what they've done here, this is a company in Africa that's put the system together, and they have been extremely successful with it. And it's a complete system. In this next video, I'll show you. And of course, it all starts with the heart of the scanner, which collects the data, and then all the data is tied into a network, a centralized network, and then within that network, all you have to do is just send signals and updates on a routine scan basis. So this next video should give you a good idea of, this is a great animation video too, by the way. Yeah, you can see the system itself is very effective, and then by having it on a platform that you can move it around to different sites, you can really utilize this thing, and it's completely power itself through self-sufficient powering through the sun, or you can, but yeah, everything is within that little carrier, and you hook it up back to a vehicle, and then you can just move it to a different location. Okay, so I think that's it for me. Gone a little bit over, but that's okay. Thank you very much for your attention. Thank you very much for taking the time to listen and hear what we have going on. If you want to find more information about what I presented today or want to see something in detail, just feel free to send me an email. There's my contact. Again, this is Nguyen with RIEGL USA, presenting all the latest news and updates for our TLS division.